Hello and good day everyone, welcome back to another tutorial by Smart Bukites in properties of material. This is a question under elasticity where we are told a cylindrical specimen of steel with diameter of 15.2 millimeters and length of the specimen as 250 millimeters is deformed elastically in tension with a force. We are given the force applied to the specimen as 48,900 Newton. Assuming Young modulus E as 207 gigapascal and Poisson's ratio as 0.30, we are told to determine the following. A, the amount by which the specimen will elongate in the direction of the applied stress, that is the change in length. Then the change in diameter of the specimen, that is change in diameter. And we are also told, will the diameter increase or decrease? We are going to solve this question right away. But before then, you will see a red button written subscribe under this video. Kindly click it and subscribe to the Smart Bukites YouTube channel. Now the solution. To solve this question, you are indeed needed to have the strains, that is the strain with respect to the length and with respect to the diameter for you to be able to solve the question. So for us to find the strain, which is A according to the length, first of all we need to find the stress. Then from that we will get the strain and we will get the change in diameter. We know that stress is equal to force over area, but we don't have the area. We have the force. We can easily calculate the area by saying area of a cylinder, since cylindrical specimen, is equal to pi d square over 4, which is equal to pi multiplied by 15.2 times 10 to the power of 3, since it's in millimeters, divided by 4. We will have 1.82 times 10 to the power of negative 4 as the area. Now the stress is going to be equal to 48,900 Newton as the force given, divided by 1.82 times 10 to the power of negative 4. This is in meter squared, the area. So this is in Newton per meter square, which is Pascal. We will have 269.48 times 10 to the power of 6, which is megapascal. This is the stress. In the elastic region, we know that stress is directly proportional strain with the constant of proportionality as Young modulus. Therefore, strain is going to be equal to the stress over the Young modulus. Since the stress is equal to 269.48 megapascal, that's times 10 to the power of 6. And the Young modulus is 207 as given from the question gigapascal, which is times 10 to the power of 9. The strain will now be 1.301 times 10 to the power of negative 3, unitless, because Pascal have gone away with Pascal. Now we can find the change in length, because we know that strain is equal to the change in length over the original length. Therefore, the change in length is going to be the original length times the strain, which is equal to 250 millimeters multiplied by 1.301 times 10 to the power of negative 3. Calculating well in your calculator, you'll see that the change in length is equal to 0.325 in millimeters also. This is the A part of the question. For the B part of the question, we are told to find the change in diameter. For this, we are going to relate the Poisson's ratio with the strains. We know that the Poisson's ratio is equal to the strain with respect to the diameter EX over the strain with respect to the length. We have the strain with respect to the length. Now the strain with respect to the diameter is going to be the Poisson's ratio multiplied by the strain with respect to the length. So now the strain is going to be equal to 0.3 multiplied by 0.325, which is 0.0975. Now we can find the change in diameter, because we know that the strain is equal to the change in diameter over the original diameter. Therefore, the change in diameter will be said to be equal to the original diameter multiplied by this strain. Therefore, 15.2 millimeters multiplied by the strain, which is 0.0975. Calculating correctly in your calculator, you'll see that the change is going to be equal to 1.484 millimeters. Then the second part of the B question, will the diameter increase or decrease? We know that if we have the original cylindrical specimen as this, after applying the force, we are going to have the length is increasing according to the direction of the force applied, while the diameter is going to be decreasing. That's why in some contexts you will see that the change in diameter is always negative to show that the diameter is decreasing. So the DD is decreasing. I hope you understand this question. For any misunderstanding, kindly drop it in the comment section. Drop your questions and subscribe to the channel. And don't forget to press the bell icon so that you will be notified whenever we have our next solutions. See you in the next video.